be full of water. It should not be just devoid of water, and also that maintaining that level is very essential. So that level is basically measured from sensors, and that can only be maintained by controlling this flow. Okay, so that is the purpose of the level transmitter and level controller.
Excuse me, sir.
Okay.
The slides are
Hmm.
not visible many a times.
Yeah, right now is it visible?
Yes, sir.
Yes, sir.
Yes, sir, it's clearly visible.
Yes,
No,
sir.
sir.
Yeah.
Only symbol of A can.
So that might be a problem with some people having like unpinned the slides. They need to pin it.
Okay, if better pin it, you pin me actually. Okay, then you can see my slides better. So is it okay now?
Yes, sir.
Yes, sir.
So that is in
Yes,
brief
sir.
about the thermal power cycle, because that is the that supplies bulk of the power in a country like India, but it has other because we have a lot of coal, but it has other disadvantages like pollution and increasing the carbon footprint and all. Now the other source of uh, power is basically the hydel power. Okay, so some of you must have seen some hydel power plant. Okay, so which basically utilizes the height of stored water. So the water is stored in the dams up to a certain height, and that water is allowed to fall. Okay, when that water falls, that potential energy is used to drive a turbine, which in turn is coupled to an electrical generator to produce idle power. If somebody of you are staying in Maithan or Hirakud or somewhere in the northeast, there is Jol Dhaka, there are a lot of hydel power plants. Okay, so where the water is stored, naturally the rainwater gets stored. Okay, and the water is made to fall through a. So it basically looks like this. A typical hydroelectric plant dam looks like this. The water is stored here. Okay, and this is basically the dam wall. Okay, and there is the intake gate is there. So by controlling this gate, the water is allowed to come through this penstock, and here there is the turbine. The turbine blades rotate, which is in turn coupled to the generator, and from the generator the power goes out to long distance power lines. Okay, so this is the typical diagram in a hydel power plant, where the water is stored in the reservoir. By controlling the intake gates, they control the flow of the water through penstock. It comes, it rotates some turbine which is connected to the generator, and the power is taken out through long distance lines. And this water again continues out of the dam in the form of some river. Okay, you must have seen some dam, in your already in your neighborhood or somewhere, or maybe once you come to IIT Kharagpur, there may be some industrial trip where you may visit some hydel power station, and then you will know exactly the. You can see directly an hydel power station. Okay, so but the basic principle is to store the water up to a certain height and then allow it to fall to rotate the turbine. Okay, clear? Hydel power.
Yes,
Okay.
sir.
Yes, sir.
Sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So then there is another very, widely known power source, which is called the nuclear power. We see a lot of uh, articles coming out in the news and all. So this is basically the power obtained by burning the nuclear fuel. So it basically works like this. So you see, so this is basically a nuclear power plant where all the nuclear reactions takes place inside these reactor vessels and all these control lots. So the lot of heat is generated. So the water that comes in is pumped here. It takes out the heat from the nuclear reaction, and then that steam is used to rotate a turbine. This turbine is coupled to the generator, and then through the generator, through the transmission lines, the power is taken out to the different places. Okay. Can you see this? The operation of the
Yes, sir.
nuclear power plant?
Yes, sir. Yes, sir.
Yes, sir, we can see it.
Yes, sir.
Yeah. So this is how it works. Okay. The fuel here is basically the nuclear source. Using the nuclear compounds, it generates the heat inside the nuclear vessel. So whatever safety is required has to be there. So the water, the circulating water is pumped from the condenser. It takes out the heat. The steam is generated, which in turn rotates the turbine. Turbine is coupled to the generator, and from the generator through these long distance towers, this electricity is taken out, to light up the cities.
Excuse me, sir. Excuse
Yeah.
me, sir. For some reason, the slides are. I can't see
Tell.
the slides. So can I leave and rejoin the class? For some reason, I can't see the slides.
Yeah, you can rejoin. You can rejoin. No need to ask that thing in between.
Okay. Thank you.
It is seen?
Yes, sir.
Yes, sir.
So that is the nuclear power. Okay, so the basic part of this turbine generator is same. The output of the generator is the power. So see, here the basic principle is the steam is generated by using the heat generated in nuclear reaction. Steam rotates the turbine which is coupled to the generator to generate power. You can see the video, the students, the animation.
Yes, sir. We
Yes, sir. What is the
Yes,
function
sir.
of control rods?
Huh?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, what is the function of control rods?
Control rods is used to control the burning of the nuclear fuel as per the requirement.
Okay, sir.
Sir, what is the role of the condenser?
Condenser means, the output of the turbine is a steam. So that steam is again condensed to form water, which is again taken out by the put in the system. Because this water, as I told, is a costly water.
Yes, sir.
Okay, so we cannot throw these out because once you take the water from the river, make it free from all dirt, and then achieve that quality of pH 7, you cannot throw it out. You have to use it. If its quality deteriorates, you will revive it rather than using fresh water.
Yes. Thank you, sir.
So this water is actually enclosed. It is not thrown out. Only if some water is lost, it is added.
Yes, sir. I got it, sir. Thank you.
Any other question?
Hello.
Yeah.
So what is happening inside the reactor vessel?
Nuclear reaction. Okay, you are burning basically the nuclear fuel to generate heat.
Hello? Hello?
Okay, so for the details of it, you have to read books on nuclear power and all. We are just concerned about that there is a source of, this is also another way of generating power. So in this curriculum, actually, we will be basically interested from this part onwards, from the generator onwards, because the name of the course is electrical technology. Okay, how this, from here, what is being done to the energy, we will be studying. So the purpose of showing all these slides is this generator is operated by different principles. Sometimes using nuclear power, sometimes using hydel power, sometimes using thermal power. Okay. So ultimately a generator has to be rotated, which is based on which principle? The generator is based on which principle? You have just finished.
Faraday's law.
Faraday's law of TM.
Faraday's law.
Faraday's law.
Fleming's which rule?
Electromagnetic induction.
Fleming's
Right.
Left.
Left.
Left hand.
Left or right?
Left hand control.
Left, left.
No. You need to go.
Right hand.
You need to go
hand.
back.
Right hand.
I am giving both the answers. So no, okay. So 50% answer should. Okay, 50%
Right
is
hand
correct.
thumb rule.
Yeah. So you need to
Sir, right hand thumb rule.
Right
right hand rule.
Right hand.
Yes, sir, right.
Yes, sir.
Now, another source of energy is basically the non-conventional sources. Okay, so ultimately in a generator, what is required is to rotate a generator. Okay, so in many places where there is a lot of wind, in many places where there is a lot of wind, you can use the wind power to generate these rotate these type of huge turbines. These are huge structures. Okay, some of you have you seen wind generator?
Yes, sir.
No, sir.
Yes, sir.
Yes,
Where?
In
Where?
Desert.
I've not
Desert.
seen in Gujarat.
Only
Sir,
on
in
TV.
deserts, Rajasthan.
In Jaisalmer, there are a lot of these.
Jaisalmer, yes.
There are a lot of these, so they are generating huge amount of wind power. So,
Tirupati.
yeah, there may be
Sir,
some
in
in the south
Tirupati.
also. So, what is being done is wind power is used to rotate huge turbines, which in turn is coupled to the generator to generate power. So, wind power is used to rotate the large turbines. Okay, so these are non-conventional sources. So there is no pollution. You just use the wind to rotate it and generate power. So wherever there is a lot of power in the Jaisalmer, or if in the coastal area, wherever there is a lot of power, a lot of wind, you can just use this and generate power. No need of burning any fuel. Okay, in many European countries, almost 70 to 80% of their the whole country's requirement is generated by using wind power. In many European countries. So in India also we should try to maximize this production of wind power wherever we have the potential for wind power.
Sir,
Yeah.
what is the mechanism behind this, sir?
Huh?
What is the mechanism behind this, sir, to generate power?
Where you have the wind will rotate these blades. Okay, the wind will rotate these blades, and these blades are coupled to the generators. Okay, and so the generator will generate the power.
Sir,
Hmm.
sir, am I
Yes.
audible? Sir,
Yeah.
what would happen if the wind suddenly, for a particular period of time, does not blow in that particular region? Then, that
Yeah,
is the
that is
question.
a very good question. That wind power has to be the wind has to be consistent. If there is no wind, then then the power it cannot generate power. So in that case, there will be no generation. At that time, the power has to be provided by using other sources. Okay, so
Okay, sir.
so all sorts of these power sources are actually connected to the generator, whether it is the wind power or hydel power or solar power or even the thermal and nuclear, all are connected to this complicated network which is called the grid. So if somebody is not producing, if the wind is not producing, then the other sources should compensate for that. So, because we have the customers, so we have always the railways running, or there is always a requirement at the home and so on.
Excuse me, sir. What will happen if the wind blows at a very high speed?
No, these are all designed, considering different types of, weather measurements. They know the weather pattern of that region. Okay, and they make up this type of structures, and obviously these structures are also designed such that they can withstand high speed also. Okay, they will be designed such that they can withstand high speed, and any high speed will be converted to energy. High speed is there.
Okay, sir.
Another form of
Sir,
Sir, I have a doubt,
sir,
sir.
yeah.
Sir, in wind power, sir,
Hmm.
only DC current can be generated, sir.
In wind power.
Yes, sir.
No, in wind power it is. I will come to that DC AC part later on. Okay, we will not introduce this now.
We can always convert that, na?
Yeah. Those things, all those conversions are possible. DC to AC, AC to DC, everything is possible.
Okay, sir.
We are
Thank you,
just
sir.
we are just discussing about the different sources.
Sir, where is wind power generally used, as in which sector?
When power is available, you can use it for any purpose. You can use it for domestic purpose. You can use it in the railways, everywhere. Once the power is there in the network, it can be used for any place. There is no specific sector. You can once you can light up at your home. You can light up in your hostel. You can light up in your power may be used in hospital. It is available once it is available in the network.
All right, sir.
So another source of power, which is basically called the solar power. You must have seen solar panels everywhere. In the large fields, in the rooftops. Okay, and some traffic signal you will find a solar powered traffic signal and all. So this solar power is what it basically does is the photons in sunlight, it hit the solar panel and are absorbed by the semiconductor materials. So the electrons are knocked loose from the atoms as they are excited. So due to the special structure of the materials in the solar cell, the electrons are only allowed to move in a single direction. We will come to the the equivalent circuit of a solar panel, solar cell. So the electron structure of the materials is very important for the process to work. And often silicon incorporating small amounts of boron and phosphorus is used in the different layers. And then array of solar cells, it basically converts the solar energy into a usable amount of current, which is basically the DC current. So that is the specialty of the solar energy. It is basically generates the DC current. Hello.
Yes, sir.
Yes, sir.
So that was the
Yes, sir.
solar power. You could see this slide.
Yes, sir.
Yes, sir.
Yes, sir.
So as somebody was asking,
Yes,
so
sir.
this solar panel power, it basically
Yes,
produces the
sir.
DC current. DC current. It basically produces the DC electricity. Okay. Now, these sources of energy, there are different types of energy sources. If you consider the energy used in any country, it is basically a mix of different types of fuels that are being burnt and converted to energy. So this is the one energy consumption source. This data I obtained for the US energy consumption. I will also give the Indian part also. That in the US, the chemical burnt is about 87%. The nuclear is 8% by using the motion 3.5%. The thermal is 0.22%. So they've reduced it. The radiant is by 0.1%. And by non-renewables, by renewables is 8.22%, non-renewables 91.78%. So that is actually the data of the energy consumption in
Excuse
US.
me, sir. How are chemical and thermal energy is different?
Chemical, I don't know the exact percentage there, because what amount of coal-based production is there. Maybe that is the coal-based production. Then this is something else.
Sir, but in thermal mode of energy, we use chemicals to get energy.
Yes.
But
sir, I guess that's geothermal instead of thermal.
Yeah, maybe. Yeah, that is the geothermal. Yes.
Okay.
I will come to the, this is some data I got from the US, this 10-year-old data. I got a very recent, capacity of India, that is May 31st to 2018. The amount of different types of energy that is being generated. So coal based is about 57%, 57.3%. Large hydro power plants is 13%. Small hydro power plants is 1.3%. Wind power is almost close to 10%. Solar power is 6%. Biomass 2.6. Nuclear power 2%. Then gas based is 7.2%. Now this is the installed capacity. That is the different types of power producing elements that are present in a country like India. And as I've been telling that the cause of worry for us is because we still burn a lot of coal, and burning a lot of coal is being strictly controlled now internationally, and we will have to gradually get rid of that, and go for other. These percentages has to change. The coal amount has to reduce, and other percentages have to rise. Okay, but there is always a requirement. Okay, we cannot suddenly stop coal. Then some of the we will also start getting power cuts. So, but one thing of worry is, I just found out this data also, that there is a lot of wastage of power in our country, and just in government installations, whether it is a government office or building or railway stations and other places, just the wastage is 1 lakh megawatt. Just wastage. You may go to the railway station and find the lights are on. You may go to your hostel. When you come to the hostel, you will find in the corridor lights are on even in the daytime. And so that is the statistics I found out, and this value I always discuss with the students in the class. So this is the value that we should target to reduce. If we can just reduce this wastage, a lot of power is generated. That power can be used in the hospital. It can be used in the airports or railway station where it is required. Like you people will also be coming to the hostel, and you will find that there is a lot of wastage taking place in the daytime. The corridor lights are on, in the toilet lights are on. So you should make sure and have, even in your own home, you will find there is some terrace light which is not required in the daytime, or some street light. So even that power, if that wastage is reduced, we can do a lot of savings just to reduce that wastage. And it does not help you in any way, because once you waste it, an equivalent amount of fuel is being burnt, and somebody is getting deprived of this power. So when you visit, when you return to the campus, you will also find a lot of power is being wasted in the corridors, even in the basketball ground or in somewhere else. Some is going on. So that is your job, will be to minimize those wastages.
Sir, the source with least carbon footprint, or the source we should look forward to, would be which among all of them?
No, even if there is a source with least carbon footprint, it may not be always available. Suppose you have solar power, you have only sun during the daytime. What do you do in the night? Your solar power is not available. Even if it may have a very low carbon footprint or no carbon footprint. Okay, as somebody was telling, suppose you use wind power. Suppose the wind is not there. Okay, suppose the wind
like
is.
The nuclear one, like the nuclear one, we have been studying that with the invent of the helium nucleus, so we can generate lots and lots of energy. So I thought, which would be the best that in future?
No, that may be there, but then nuclear, we may have some other environmental issues. Okay, so then those things have to be protected, and that may need again a huge amount of investment. But anyway, so
Sir,
those
how
things.
is the electricity generated through gas?
Huh?
Sir, how is the electricity generated through gas?
It is burning the gas. Okay. It is burning the natural gas, again burning the natural gas to produce steam too.